You have a 9-month-old baby girl in your intensive care unit, and suddenly her lungs start to fill up with blood. Her blood oxygen level is dropping fast, and you try to get a tube down her throat while your team sets up the heart-lung machine. Her lung is almost completely filled with blood, damaging her capillaries, and suddenly she goes into cardiac arrest. You start CPR, and before you're able to hook her up to the machine, she has lost too much oxygen and has already acquired brain damage. HuffingtonPost.com of June 27, 2012 reports that this is exactly what happened to John Kerr in October of 2006. This motivated him to come up with a unique discovery. eScience.com reports that an oxygen level below 85% demands outside source of oxygen in order for the patient to breathe. Kerr came up with an oxygen microparticle that can be injected to humans who cannot breathe on their own. Today, I'll give you a brief background about what oxygen is. Then, I'll talk about how oxygen injections were used in the past. And lastly, I'll talk about the oxygen microparticle that will help save our future. I better get an oxygen mask handy because I'm about to give you guys a mouthful of information. Let's start off with what oxygen is. Here are some basic facts. As printed in Biology of 2008, oxygen is one of the 4 elements that make up 96% of all living matter. Humans, along with plants, bacteria, and other animals, depend on oxygen in order to survive. It was 2.7 billion years ago that photosynthesis released oxygen into the air, and water bodies let out oxygen as a gas. For some of us, it's laughing gas, or the other kind of gas. Oxygen has a lot to do with the human body. In the book Chemistry 2009, says that oxygen makes up carbohydrates, fats, protein, and DNA. Oxygen is needed in our muscles, blood, and all vital organs in order to function. We use oxygen to oxidize red blood cells and produce energy throughout the day or throughout the speech. In the textbook Chemistry 2009, it is explained, as oxygen is inhaled into the lungs, hemoglobin binds to oxygen, carries it throughout the body, and carbon dioxide is released from the lungs. Now that you have background information about what oxygen is, let me tell you of how oxygen injections were used in the past. Doctors had previously tried to inject oxygen gas with needles into patients. According to PopularMechanics.com, World War I doctors tried to inject oxygen gas into the patient's blood. Instead of providing oxygen, well, you guessed it, it provided gas. It produced bubbles that blocked blood flow and caused deadly gas embolisms. As noted in the Canadian Medical Association Journal of 1914, Dr. Howitt injected oxygen into a patient who was 66 years old and suffered from lobar pneumonia. She had a temperature of 103.5 degrees and a rapid pulse. Dr. Howitt injected oxygen from a trapped cylinder, traveled through a tube, and was inserted into her skin. The injection helped with dropping her fever by 1 degree and lessened her heavy breathing, eventually getting rid of her pneumonia. Unfortunately, this method only absorbs oxygen that is needed, and it may cause emphysema, which is a lung disease that makes it, as Maroon 5 would say, harder and harder to breathe. The study Intravenous Oxygen of March 1950 mentioned that a man named Moriani was the first to inject oxygen into a human. He injected a total of 120 cubic centimeters, which is equivalent to 100 cubic centimeters per hour. The patient suffered with tuberculosis and did not get worse from the injection, but ended up dying the next day. Now that you know of how intravenous oxygen was used in the past, let me tell you of the new oxygen microparticle that will help change our lives. I mean, you're probably thinking, how am I supposed to breathe with no air? The new research on oxygen will help save lives in the future. On June 27, 2012, popsci.com reports that researchers came up with oxygen that can be immediately injected into the patient's bloodstream. The 2 to 4 micrometer creation is made up of a lipid capsule that is basically a fatty membrane that surrounds a bubble of oxygen and is injected within a solution. The microparticle was made with high-intensity sound waves that blended the oxygen and lipids together. PopularMechanics.com of June 27, 2012 described that this works because the phospholipid fluid is closest to blood plasma and helps red blood cells bind to the oxygen, bind to the oxygen, but before any bubbles start to form. They tested the solution in rabbits whose blood supply was, or whose air supply was cut for 15 minutes after they were sedated and paralyzed. Seven of the rabbits received oxygen and they didn't have any complications. 6 of the rabbits in the control group didn't receive oxygen and suffered cardiac arrest and brain damage. One of the rabbits who received oxygen suffered with cardiac arrest due to a carbon dioxide buildup that the animal could not exhale because he was unconscious. The important in the June 27 issue of Science Translation Medicine, Kier explains how the oxygen microparticle is only effective with non-working lungs. The concern here is that the oxygen microparticle could help by 20 to 30 minutes in order to figure out how to stabilize the patient in the meantime. I mean, that's enough time to set up a heart-lung machine or perform a surgery that can open the patient's airway and provide them supplemental oxygen. Today, I gave you a background of what oxygen is, talked about how oxygen was used in the past, and gave you information about the new oxygen microparticle. Let's take a deep breath. After the microparticle has been tested enough to be safe on humans, we can be sure that other cases like the 9-month-old baby girl who suffered with pneumonia could be saved from cardiac arrest and organ failure.